All right, so these are some pretty cool problems here, and you'll all at some point maybe you'll buy a home, and homes generally aren't great investments. They can be, but you really have to buy the home at the appropriate time, and hopefully it goes up. And there are some real estate locations where homes go up a lot over a short period of time, but in many cases homes just maybe appreciate just by a little bit. If you're looking at interest rates, like 0.5% per year or 0.1%. So they're really not good investments, but they're good investments in the sense that, when you have it all paid off at the end, you're going to have a nice asset, probably over $100,000. And you have to pay to live somewhere anyway. So it's generally considered an investment when you buy a house, as long as you keep up and it's in the neighborhood that you're in continues to be a place that's in demand. So we're going to look at car loans. We're going to look at home loans here today. All right. The other thing is that the present value is it's P in the formula, but it's present value in the TVM solver. And you'll notice that nowhere in here will you see future value. So in all of our present value problems, the number that you're going to put in for the future value is 0. All of the variables here are defined exactly as we've defined them before. And then I've added some things about the TVM solver. Particularly when you're using this, you always want to circle the end at the end. And what does the alternative is then? Molly, tell me what's on your calculator. What does it say that's equal to 1 at the bottom?
It says PMT end, and then we have to use 1 for that.
Okay, yeah. So on the newer on the phone apps, I think you have to put 1 here, and always leave it 1. Yeah. Most of the time for these problems, the payments per year, compounding per year, because if you're dealing with homes or cars, you make monthly payments. So usually these last 3 numbers will be like this: 0, 12, and 12. 12 payments per year if you have a mortgage, 12 payments per year if you have a car.
It's kind of hard to see. Could you move it up a little bit? Thank you.
Mm-hmm. All right, the interest rate on cars, you want to consider that. A lot of times dealers, they'll send your information, your credit information out to many lenders, and the lender that comes back with the lowest rate, that's the one that they're going to take. And right here for the payment, I said that's the deposits in the formula. And remember to use a negative for cash out for the payment. As before, the interest rate, if the annual percentage rate or the stated interest rate for the year is 9%, we want to use 9 in the I%. We don't want to convert it to a decimal with the TVM solver. The number of payments is the N times the T, where the N is the payments per year, compounding per year. All right, let's go through some of these problems. We did a couple at the beginning, but suppose that you borrow $30,000. The amount that you borrow, the amount of the loan, is equal to the present value. If you have any loan, generally they'll allow you to pay it off at any time. So if you have a home and you decide that you have to move after 5 years, then you want to sell the house. You can, if you sell the house, you end the loan. And the amount that you owe on the loan is called the present value at that time. For 4 years, at 8% interest for the purchase of a car. Find the monthly payment and the total interest for the loan. They're always going to ask you, after you've paid off on a loan over the entire length of the loan, they're going to say, okay, how much of that was principal and how much of that was interest. They'll always calculate that. All right, so let's enter these numbers into the TVM solver. We're going to almost exclusively use the TVM solver in this section. And we know that N is equal to M times T. And we are going to make monthly payments. So N is equal to 12. I guess we're calling this a little n, not m, times the number of years, 4. So we should get 48 up here. 4 times 12. The interest rate is 8. It's a very high interest rate for a car these days. The present value is the present value of the loan. In some of your problems, you're going to do like Carly there, and you're going to make a down payment. And if you make a down payment, you have a smaller loan. So that changes the present value. In this case, there's no mention of a down payment. So we're going to finance, as they say, the entire $30,000. The payment is what we're looking for. At the end of the loan, nobody will owe anybody money. And the payments per year, compounding per year, we're going to make monthly payments. So therefore, that's 12 per year. 12 payments per year. And at the end of each period, we calculate the interest. All right, let's plug everything in and determine what the monthly payment is. So 48 months, 4 years, you'll have this car paid off. Interest rate is 8. Present value 30,000. Notice the present value is a positive number. In our earlier section, it was a negative number. And the payment is what we want to calculate. So with the cursor right in this row, we're going to do an alpha solve. And there it is, $732.38. Okay, so once you get the number from the TVM solver, go off to the side and, write down that number in the correct form. Correct, rounded to the nearest penny. Now, the next calculation that we do in this problem, because it asks you for the total interest that you paid, we first have to figure out how much we paid over the length of the loan, their total payments. So we'll calculate that first. So the total payments over 4 years, that's 48 months. And then every month we made this payment of $732.39. So you did take out a loan for $30,000, but it turns out because of interest, you pay more than the $30,000. Let's see how much more. This is not a TVM solver problem. This is an arithmetic problem from here. So take the 48 and multiply by 732.39 and 35,154.72. All right. So that would be the total payments. Now those total payments are made up of the principal on the loan and then the interest. So what you do is you subtract the principal. Remember that the principal was the original debt that we took out. The bank gets its money, the mortgage company gets its money by charging you interest. In this one, they're getting a nice rate. So just go ahead and subtract those two numbers. Too hard in this case, because we're subtracting 30,000, and everything left is interest. So, unfortunately, when we take out a loan, we pay a lot in interest. In this case, over a 4-year period, we had to come up with an additional, over $5,000. All right, so they want this answer, the monthly payment, and then they want the total interest for this one, both of these. The next one has just a slight wrinkle to it. And this is the one that CC mentioned that, hey, I saved $6,000. And in this case, it's $12,000 for a down payment. If you save that money, that's less money you have to borrow. So if the car was $37,925, let's say with taxes and everything else, we're assuming here, but then you've got the down payment. So when you subtract those two, then it turns out you only need to borrow $25,925. It was the what the loan would have been, but then we paid down at the beginning 12,000. So that means over the life of the loan, we're going to pay a lot less interest than if we borrowed the whole amount. All right, so the present value then is related to the amount that we borrow. And so that's going to be the amount after we subtract the down payment. All right, so you can get a 5-year loan for a rate of 6.58%. And then find the monthly payment. So the little n is 12, and then that makes the payments per year and compounding periods per year to also be 12. All right, I think we have all the information that we need. It says find the monthly payment and the total interest. So there it is again, that kind of a two-step problem. Find the monthly payment, we use the TVM solver. And this is a tricky one. A lot of students put this one in last because it actually involves multiplying two numbers together. The n times the number of years. All right. So this is like Veronica's loan where she took it out for 5 years. All right, I%, that's the interest rate. This one is probably the easiest for students to put in because a lot of times they just give you that number. The only error that students make here is, they convert it to a decimal first. And in the TVM solver, you never convert the rate to a decimal. The present value of the loan. And this is after we pay down the down payment. So that's 25,925. The payment, find the monthly payment. That's what we're looking for. And then these last three numbers are almost always going to be the same. The future value is 0, the payments per year, the compounding per year, those are going to be 12. Again, because we're buying a car. So assume that you're going to see monthly a lot in these problems. And then we'll get the TVM solver out to calculate the monthly payment. 60 months, 6.58 interest rate. Present value of the loan, 25,925. And then I don't even have to change these bottom numbers because they usually match up. With all numbers known except for the one, we put the cursor to the one we want to calculate, and then alpha, enter, alpha, enter. All right, so there's the monthly payment, 508.22. With the TVM solver, we can really do these problems carefully. In the days before this calculator, we had to work these out using this formula. And every problem was different. Sometimes we had to just plug things into the calculator. Sometimes we had to solve a linear equation. Sometimes we had to use logarithms. So it was a mess. All right, so I'm going to take this number and write it in the right form, rounding it to the nearest penny, and then I'll go ahead and find the interest. Total accumulated payments over 5 years equals, bring it up a little bit, the payment we made times the number of times we paid it, and then subtract the amount of the loan, which is the present value of the loan, and everything else would be interest. 508.22 times 60, 30493.20. All right, so the interest, we're going to take that 30493.20 and subtract the present value of the loan, which is not the 37,000, it's the 25,000. And so there's the interest amount. So you can see, borrowing money is not cheap. Wait till we do a house example. But you can see just over in 5 years here, because you're taking out the loan for this 6.58%, you end up paying the bank $4,568 Okay, you know, and then they're going to give you some problems like this. Let's say that you want to borrow, and this is where this class really comes in, because one of the things that you should negotiate when you actually go buy a car, if you do have to borrow money, is ask them if, you know, what kind of financing they have. And so, for example, you can get a 3-year loan for 6.1% or a 5-year loan at 7.2. If you're going to borrow the money longer, they're going to want a higher interest rate. So you can actually compare two loans. And the way they want you to compare it is to compare the total amount that you paid over the two loans and then choose the cheaper one. All right. Well, this doesn't take very long, so let's just go ahead and do it. We have the present value is 40,000. There's no mention of a down payment, so we're going to finance that entire 40,000. That becomes the present value. We have monthly payments, so little n is 12, and that means payments per year, compounding periods per year is also 12. Then you've got the two different loans. You have loan A and loan B with the different interest rates and with the different, we call them terms, the number of years you're paying on this. So for this one, you have T is equal to 3, a 3-year loan, and you have R is equal to 6.1%. For the second one, you have T equals 5, 5-year loan, and the R is equal to 7.2%. All right, let's calculate the monthly payments. Now, if you're going to pay off a $40,000 car in 3 years, you should expect that you're going to have a higher monthly payment than if you stretch out those payments over 5 years. I mean, the reason we have these long loans is to get our monthly payment down. But in the process, you end up paying a whole lot more in interest. So let's take a look at the implications of these. What's important in this problem, I think, is the term, the 3 years versus 5 years. Okay, let's look at the loan. Loan A is 3 years, so 3 years of monthly payments. That would lead to 36 monthly payments. The interest rate on that loan is 6.1%. The present value is the 40,000. Then the payment is what we're after. Future value 0, payments per year, compounding per year, both equal to 12. Before I calculate anything, I'm just going to go ahead and write the same values. Look at, what's different, what's the same. Present value is the same. Still trying to calculate the payment. Future value is still 0, payments per year, compounding per year, equal 12. In loan B, it's a 5-year loan. So 5 years worth of monthly payments. So that would mean 60 monthly payments. And the interest rate on that other loan is 7.2. Now we know this loan over here is going to have a higher payment. It's because you're paying off the entire loan in 3 years as opposed to paying it off in 5 years. So let's go ahead and calculate each. And then the most important, well, not the most important thing, but the thing we're going to consider is how much did you totally pay for that car using the two different loans? And this is all the number crunching that you do beforehand so you can make informed decisions once you go into the dealership. All right, let's start with this one. We've got 36 and 6.1 on the interest rate, 40,000, and everything else matches up. So we're going to calculate the payment. And the payment is negative 1218, 6907. So the payment is 1,218 and 69. So if you do want a pricey car like a $40,000 vehicle and you want to pay the loan off in 3 years, it's going to cost you about $1,218 every month. But you'll have it paid off. in 3 years. Good news. All right, now we're going to calculate the next one, and you're going to get a sense of why people take these loans out over a longer period. So 60 is the N. Remember, that's since payments per year, compounding per year is 12, that 60 means 60 months. Interest rate is 7.2, and the payment is $795.82, and so on. So the payment here is $795.80, we'll call it 3. So you can see if you take it out over 5 years, your payment is much lower than if you take it out over 3 years. The advantage of taking it out over 3 years is that you pay off your car sooner. The other advantage is that you save a whole bunch in interest. So let's calculate the interest in each one. All right, so the interest for A, what we're going to do is we're going to take our monthly payment, and then we're going to multiply it by the number of times we made that payment, and then we're going to subtract the 40,000, which is the principal. So everything else is interest. All right, so this is interest on A, and this is interest for the B loan. For the B loan, we're going to make payments of $795.83, but we're going to make 60 of them because we have to take this loan out over a 5-year period. And again, we're going to subtract out the principal, so everything that's left is the interest. So the interest calculation is arithmetic. Just do it on your home screen. There's no need to do anything with the TVM solver. Type that in, 1218.36 minus 40,000. So the interest on the first loan, let's try that again, is $3,872.84. Okay, so here's the sad news on that second loan. $795.83. We make that payment 60 times. Minus the principal. So here's the cost for taking out a longer loan. If you take out a longer loan, then you end up paying a whole bunch more interest. And you can see that it's actually double the interest here. So instead of paying $3,800 in interest, you're paying twice that, $7,700. But that's the cost of borrowing money. So if it's the $700 payment you can afford, then and the $1,200 you can't, then there's nothing you can do. You have to go with the longer loan. If you can't afford the $795, then you have to settle on a cheaper car. Okay, the next context, basically we're going to be doing the same thing, monthly payments, but now we're going to buy a house. And instead of just calling it a car loan or a house loan, they call it a mortgage. And a mortgage is a contract. It's several different pages thick. You got to sign your whole life away, and it's scary because you're owing the bank $180,000 or something. So what we're going to do here is we're going to calculate the total interest over 30 years. And so just imagine paying monthly payments for 30 years, staying in the same house. At the end of the 30 years, you'll have your $180,000 paid off. But how much did you actually pay in monthly payments over that 30 years to buy that house, that $180,000 house? Let's take a look. All right, a lot of times the banks will require a down payment. And if the down payment is less than 20%, then a lot of times they'll charge you private mortgage insurance, which is just another fee that you really don't need. When I got my first loan, they were charging me $50 a month just for mortgage insurance because I was a first-time borrower and they didn't know that they could trust me. And so they said, as soon as you pay down, you're making monthly payments, as soon as you pay 20% of the loan amount, then we'll take away that private mortgage insurance. So I had to physically call them up and say, hey, I've reached the magic number. Can you get rid of that fee? And they did. All right, usually there's a down payment, and the down payment is a percentage of the loan amount. So if the condo was 180,000 and you were going to borrow some money, the bank's not going to give you a loan for the 180, because then the entire financing of the condo would be on the back of the bank. And the bank wants to have, as they say, they want you to have a little skin in the game. They want that house to be, they want you to pay something down on that house so you don't just walk away from it. So the first calculation is to multiply 5% times the 180,000. And, you know, that turns out to be a nice, huge chunk of money. What is it? Is it 9,000? Half? Oh, 900? More than that. 9,000? All right. So it's always good to save some money, because if you want to buy a house, you have to have a big chunk. Now, I don't know if CC was required to come up with that 6,000 down payment. Probably not. But it's always good to have it so that you can pay down the loan amount. All right, so there was a $180,000 home, and the down payment was $9,000. So if you do the subtraction here, the present value of the loan is no longer 180,000, it's 171,000. So if the homeowner loses their job, can't make their payments, has to sell the home, they could end up losing the 9,000. That's how much. So they just walk away from the home. They don't get that 9,000 back. Plus, if you walk away from a agreed upon loan, you've signed all the papers, and you walk away, it'll destroy your credit rating. And you can't get credit if you have a bad credit rating, or you can't get a loan. All right, what else do we have? Moving on, the cost of the condo is financed with a 30-year fixed rate. That means it's fixed, it never changes, of 8%. All right, we've already done the required down payment in part A. So all this information over here was the calculation of the A. The next one, part B, we did that here. That was to calculate what the amount of the mortgage would be. So it's the original selling price and then minus the down payment, or what the loan would have been minus the down payment. All right, now we calculate the monthly payment. And this is the one where we use the TVM solver. We have to use that formula. And the TVM solver is the quick formula calculator. All right, this one is going to be big. 30 monthly payments, 12 payments per year for each of the 30 years. So if you stay in that house for 30 years, then that means you're going to make 360 payments of whatever the payment is. The interest rate is 8. Present value is not the 180,000, but it's the 180,000 after we put down our down payment. So we're only financing 171,000. Payment is what we're calculating. And then at the end of the loan, we will owe nothing. They will owe us nothing. The future value is 0. And the payments per year, compounding per year, since monthly payments are going to be made, will be 12. All right, let's put in all the numbers we do know and then calculate the one that we don't. All right, so when I'm doing these, I always write the full length of the screen, and just to indicate that, you know, that is not the answer there. The answer is when we take it out of there and we put a $sign, insert the appropriate commas, and then round to the nearest penny. There's the answer. To the payment piece, right? That's the That's the part D. Yeah, I know there's no part C, but it was because I took it out. Yeah. And I also took out a blurb here that referred to C. Anyways, it was if you had to play points. And I just decided we're not going to deal with that because most of the loans that you get these days do not require points. Okay, total cost of the interest. We've done this 3 times already, and it's always the same. The interest equals the total payments. This time it's over 30 years. And then we subtract the principal. And that was the original amount of the loan. It's always how much interest were you charged on the loan. All right, the total payments, we have to make a payment of $1,254.74 every month for 360 months. So if we make that payment for 360 months, this is the total amount that we have to spend. We're going to subtract out the principal, which is the $171,000, and everything else left is the interest. And here's the sad news. When you buy a $171,000 house and make all payments as scheduled, that house actually cost you $451,000. So let me write that one down. 451,706.40. And when you subtract these two, you get $280,706.40. This is not unusual. When you take a loan out over 30 years, since you're paying interest in the earlier months on 171,000, turns out that you actually pay more in interest by $100,000 more in interest than you do to actually pay off the loan. So it's very, very costly to borrow money. And that was all the work for E. Okay, and there's one last problem here. And this is an amortization table. This is something that that we can create so that you can figure out what the present value of the loan is at any time. And usually we wouldn't do these by hand, but we would do them on some kind of calculator program. So maybe I'll just go ahead and take you to one. There it is. And let's say the loan is a mortgage and we're going to borrow. I'm looking at problem number 16 now, and the total amount borrowed. There's no mention of a down payment, so we're going to borrow the entire 160,000. We're going to take it out for 30 years, and the interest rate is 4.2%. And you got to avoid all these buttons here because they're trying to get you to go to a site. So what we want to do is to calculate. So I'm going to calculate, and a couple of things I'm going to write down. You can see up here they have the payment, $782.43. They have this thing here that says interest paid, $121,674 interest. It says the total of 360 payments would be $281,674. And the last payment will be made in September of 2050, 30 years from now. But what's nice here is this schedule. And the schedule down here, this is what you're going to be asked to calculate in this problem number 16. And you'll notice that it is a 30-year loan of monthly payments. And so as you scroll through this, you're going to see it goes down all the way to September of 2050. At that point, the balance will be zero. But the other thing that you notice is at the beginning of the loan, your payment, and they told us that the payment up here was $782.43. that payment consists of interest and principal. So in every row, when you add the interest and principal, you have to get the same amount. This number up here, the 782.43. But as you go through, every year or every month, you pay off a little bit more principal. So the next month, you don't owe as much interest. So the interest amounts are going down and the principal amounts are going up. So in your first couple of payments, most of the payment goes right to interest, goes right to the bank. All right, I'll leave this up here. And then as you get further down the loan, the interest is tiny and most of the payment goes to the principal. This is how a fixed conventional loan works. All right, I want to recreate these numbers here. And notice I'm only asking you to do the first 3 months. So we're going to do these 3 months right here. And hopefully in the end, we end up with 159,330. Of course, that number is rounded. So creating this table is what we're going to do. I can go back to it so that we can compare answers. But let's go ahead and work through this problem. The first part of it is like we've done in the past. We need to find the monthly payment and then the total interest. It's nice that they've calculated that over here for us. This is the total payments, interest, and monthly payment. Let's see if we can generate those same numbers. All right, so down here. First, for part A, we're taking out a 30-year loan of monthly payments. You're going to find that 360 is a popular number that we use for N because a lot of mortgages are 30 years. Interest rate is 4.2. The present value of the loan, there's no mention of additional fees or a down payment. So we're just going to finance the entire $160,000. Payment is what we want first, and then we can calculate the interest on that. And the last three numbers have consistently been 0, 12, 12. All right, we're going to calculate the payment. Interest rate 4.2. 4.2 is a much more reasonable number these days because interest rates are historically low. Like you can get a 30-year fixed mortgage for 3.5% or 4%. So they're really, really low for homes. 160,000, and then calculate the payment. All right. Boy, that looks familiar. 782.43. Remember what it gave us? 782.43. So the TBM solver calculates things just like these fancy websites. All right, I'm just going to write 782.43. All right, part 2 of this problem asks us to calculate the interest. So the interest is equal to our payment, 782.43. And then we're going to multiply that by 360 and then subtract out the principal, the amount of the loan. So this is all principal that we paid off. Everything else is interest. 782.43 times 360. I'm going to write this number down, 281,674.80. And then we have to subtract the 160,000. And we get 121,674.80. All right, I just wanted to go through these calculations so you can see that the total interest paid, 121,674. Monthly payment we got over here. Monthly payment from the amortization website, same. Total payments, same. Okay, the reason I really wanted to do this problem was so that we could do the amortization table. So here's how it works. If the interest rate is 4.2%, then in the first month, you have to pay 1/12 of that. Each month you pay 1/12 of the interest rate, and they break it up by month and throw that into your monthly payment. So the payment here is not going to change. And all these amortization tables, they look slightly different. They'll include, they always include the interest, the principal, and the balance, but some of them don't include the payment because the payment is always the same. Whatever you agree to be the monthly payment, that has to be the same throughout the entire 360 months. All right. And here are some new calculations that you won't use with the TVM solver. So the interest is, the current balance is 160,000. That's how much you owe them. And so they're going to charge you interest each month on that. What are they going to charge you? You take the interest rate, 4%, and divide it by 12. And that gets you the monthly interest rate. And since we're making monthly payments, why not just divide the whole yearly interest rate into 12 and then figure out that's how much we're going to charge you each one of those months. So that's the interest rate, and then we have to multiply it by the total amount we owe. And for the first payment, we owe all $160,000 of that. So if you take 0.042 divided by 12 and multiply that by $160,000, you get $560. I don't know if you remember, but that was the number in that spot. All right, I'm going to write out the numbers here so that you can see the calculations. If this is your payment, and this is how much goes toward the interest, then everything else must be the principal. So we're going to take 782.43, take out the interest, and then everything else is the principal, 222.43. Okay, now this is the principal. This is part of the 160 that we paid down. This was the bank's fee, the interest rate. So when we write the balance again, we used to owe $160,000, but now we're going to subtract out the principal that we paid in our payment. So we no longer owe $160,000, but rather we owe $159,777.57. Repeat. And so we just do the same thing for each row. It's that, except this number comes down. So let's do another one. We take 4.2 divided by 12 to get the monthly interest rate, but now we only owe $159,777.57. So there's that number times 0.042 divided by 12. So notice how the interest came down by pennies, and we're always going to round these numbers off. If you looked in the amortization table, they don't worry about pennies in the display, but they do use them as they go from row to row. Otherwise, there would be amazing rounding error in the entire table. All right, and then we're going to subtract this from our payment, 782.43, and that's going to give us 223 point, looks like it should be 21, but I'll just leave it that way. And then we take the previous balance, which was 159,777.57, and subtract again the principal. It looks weird because we're subtracting such a small number from a huge number. And then the new balance would be 159,554.37. So very, very, very tedious calculations, and this is why we rely on an amortization table. All right, go ahead and give me the last row, see if you can do it. This number, and this number. Right, yeah, I went to share screen because those these three values here that I have, you can compare these to what we have in our table. So even though I switched to the share screen, I went back to the amortization table, you can match up our numbers with theirs. And you can see we match. They've rounded everything to the nearest dollar, and we're rounding to the nearest penny. But other than that, so you can see you're going to get 558 and some change for that first one, 224 and some change for that second one, and then you're going to get for the final 159, 330. So go ahead and do these and you'll get a sense. Look at these numbers are changing. You know, after 3 months, you still owe almost all $160,000. You know, maybe 600 less. And you've made 3 payments of $780. It doesn't come back at all. Okay, so here are the last 3 numbers. You can see there's very little difference, only pennies in the first 3 months. Remember, if we did the entire table, we'd be going 1, 2, 3, dot, 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 all the way down to 360, 360 months. These calculations are identical from row to row. The payment is always the same. The payment is equal to the interest plus the principal. They call it the debt payment. I call it the principal. And then it's only, the balance goes down only by the principal that you pay off, not by the interest. The interest is the fee that goes to the bank. And this is called an amortization schedule.